Hi and welcome back to another LeetCode video. This is just me practicing for interviews. I'm kind of going through the motions that I would during interview where I read the problem description, ask clarifying questions, come up with different approaches, discuss their trade-offs, do a runtime and space complexity analysis before I start writing a single line of Python code. Then I write the implementation, explain it, and walk through it with an example. The mental debugger. So basically, this is what this video is. I think we should be able to solve this. This is a medium problem. It's a greedy problem. LeetCode 1899, merge triplets, form target triplet. Right, so step one, let's understand what we are dealing with. A triplet is an array of 3 integers. You're given a 2D integer array triplets, where triplets is a triplet of ABC, describes the eth triplet. Also given an integer array target, XYZ, that describes the triplet you want to obtain. To obtain target, you must apply the following operation on triplets any number of times, possibly 0 times. Choose 2 indices, I and j, that are not the same, and update triplets j to become the maximum. So that so we're taking the component-wise maximum of 2 triplets for each of the values. We're taking the max of the first values, the second values, and the third values. Cool. And return true if it's possible to obtain the target triplet XYZ as an element of triplets, or false otherwise. Okay, cool. So it looks like we need to combine triplets using this max operation to form the target triplet. Okay. So question that I would have now to the interviewer would be, okay, well, I mean, is it guaranteed that we find a solution, or obviously not, otherwise it wouldn't be a challenge, right? But what are the range of the values maybe inside those triplets? Is it guaranteed that we have at least 1 triplet? Do we always have a target? What are the value ranges, etc., etc.? That's what I would want to know. And on LeetCode, that information is given in the constraint section here, and it tells that okay, we have at least 1 triplet in our triplets array, and all triplets have the same format where they have 3 values. And the values themselves are between 1 and 1000. Cool. So I'm thinking, so I guess I can combine as many triplets together as I want, right? But doesn't that just mean that I have to find a triplet that has the same value A as I have in my target X? And then I have to find possibly another triplet where the target value Y is B? Oh, I think so, except if I have a match where, yeah, I can see how this can go wrong. So if you have a triplet, let's say the target is, I don't know, 888, something like that. That's the target. And then if I have a triplet 8, 5, 5, that's fine, right? I can use that to obtain the first letter, the X. But if my second triplet is maybe minus 9, 8, 8, then I could combine the two and I would get the target triplet. But what if this was a plus 9? Well, in that case, it doesn't work, because then I would get a target triplet that has a 9 in the beginning, which is not real. So I have to check both whether, let's say I iterate over all of the triplets. I have to check whether A, the first component, is smaller or equal to the target first component. And if that's the case, then I have to make sure that the other components are not larger than the other 2 components of my target value. So I basically just have to iterate through the array one time. And I just have to keep track of which of the target values XYZ I can actually get from a triplet. So that seems easy enough. So I guess we'll have an O of n approach here. And I don't even think we need a lot of space. We probably can get away with constant space as well. Time and space. Yes. A more naive way would be to, look at all triplet combinations, but then it's an n factorial. No, not quite, but it's a much larger number of different combinations that we can take. And to go through all of them would be very, very time consuming. So yeah, I think this is the right approach. Linear time, constant space, I don't think we can do any better because there's no information in triplets that we can otherwise exploit. No sorting, no nothing like that. So, okay. Right, so what do? Well, we iterate over triplets. And maybe we should keep a result array. And you'll remember whether we were able to use any of the triplets to reach the X component, the Y component, and the Z component of target. Now we just iterate over the triplets for X and triplet. Now we need to deal with the cases. So we need to throw away all triplets that have a component that is larger than the corresponding component in the target area, right? And we know we only have 3 components in it. So if target position I smaller than triplet at position I, well, that's no good, right? That means we have to throw this away. And in that case, I think I'll set a filter flag. And well, if we need to filter this triplet, we'll just skip it. Now, otherwise, now we know if the triplet passes the filter, that means all the values in the triplet are smaller or equal than the values in our target component-wise. Right? So now we have to check if they are the same. So for I in range 3, if target at I is the same as triplet, well, then we have a match. That means we can use the triplet to get the component at that position correct. And just say true. And then at the end, we just return, are all of the values true? All we need, I believe. Yeah, let's run the tests. Triplets typo, right? Yeah, I'm always rushing this part. I don't know if LeetCode does it or not, but normally, in an interview, you have to go through the code line by line to make sure that catch all of these. All right, so ta-da, test cases pass. Very nice. So let's submit this. Nice. So, and we have a working solution. So that's what makes this greasy, I suppose, that we just, grab the triplets that work and immediately update the result. Could also say here, if all result return true. Could do it here in this place. If not, result at index I and target. Then we set it to true and then we perform the check. This would allow us to terminate earlier. So let's run this test. It doesn't change the runtime complexity, but maybe we get to better runtime on LeetCode with that. Oh yeah, boom. So we now very, very fast. Cool. So yeah, I guess that the conclusion.